But before we do that, let's go back to the first 3 slides to review our work. So for slide 1, you can check your answers for these first 4 problems. And I'm going to talk about number 5. And so it's asking you based on any patterns that you notice. So if we look at this graph, and you just look at the shape that the dots are kind of making, you can see that they're kind of going up in this upward direction, going up and to the right. And so if we check our axes, what that's telling us is as we increase on the x-axis, as the total number of COVID-19 cases increase in various countries, then the total deaths, which is the y-axis, that's also going up. So the more cases that a country has, then the further right to the right that they are, they're also more likely to be further up in the graph. And then if we think about what's happening in real life, that makes sense because the more cases that a country has, then the more people are likely to die from the disease. So that's why we have that relationship and that pattern. For slide 2, the linear regression line, the line of best fit, that's the line that comes as close to as many points in your scatter plot as possible. So for our graph on the right here, that line's going to be somewhere like this. It can be a little bit of an estimate, but you should have a positive slope, and it should be right around here. A good rule is that you want as many points below the line as there are points above the line. For slide 3, outliers are data points that are far away from the main set of data points. So here we can see that the United States, unfortunately, is an outlier because it has a significantly more COVID-19 cases as well as deaths. So that's why it's all out here, whereas the rest of the countries are all here. Okay, so now let's fill out slide 4 together. The correlation coefficient, and we always use the variable r for that. So sometimes it's also called the r value. And that number for the r value, tells us how closely the two variables are related. And it's on a spectrum. The lowest the r value can be is -1, and the highest it can be is +1. And right in the middle is 0. And we're going to start by filling out the middle first. If the r value is somewhere around 0, the scatter plot's going to look like this, where there's no real pattern that we can see. The dots are kind of just everywhere, all over the place. And when that's the case, the correlation type is we would actually just say that there is no correlation. And then the relationship between the variables, as x increases, so as you go further along the x-axis, y is unpredictable. We can't determine anything about the possible y value based on the x value. A real-life example of two variables that have no correlation would be something like shoe size and someone's grade in math class. Right? Your grade in math class is based off of your work and your understanding. It has nothing to do with your shoe size. And so that's why if we put everyone in your class, their shoe size compared to their grade in math class, it would look something like this with dots all over the place. Okay, so now let's go back to the left. So the lowest the r value can be is -1. And if the r value is -1, the correlation coefficient is -1, the scatter plot will look something like this graph, where all of the points are on or very close to being on a line with a downward negative slope. And this type of correlation, you can say, is a strong negative correlation. And what this means is, as the x value increases, as we go further to the right on the x-axis, y decreases very closely. And a real-life example of this is distance traveled and the distance remaining that you have to travel. And so you can think of it as you travel further, your distance traveling goes up and up and up, and then the amount that you still have to go is just going to go down and down and down. And it's going to decrease very closely or very exactly with the distance that you're actually traveling forward. So, and in between a strong negative and no correlation is we can also have a weak negative correlation. And this is usually when the R value is somewhere around negative 0.5. It might be a little bit less than that or a little bit more than that. And in the scatter plot, what that would look like is the points do make some type of pattern. We can tell that they're going down, but notice how compared to this one on the left, in this graph, they're not as close to the line. They're a little bit more spread out. So what's happening here is as x increases, the y values are also decreasing, but I'm going to say that they're decreasing loosely instead of very closely like they are here. And a real life example of this might be temperature and number of jackets sold at stores. So if we think about as the temperature increases, so as the x increases, it's getting warmer and warmer and warmer. And then as it's warmer, fewer people are buying jackets because they don't need them anymore. So that's why the number of jackets sold at stores would decrease. But it's not going to decrease exactly by the same amount every single time because people can be a little bit unpredictable, right? Some people still like to wear jackets when it's warm outside, or maybe some people already have jackets. Okay, so now let's go in the positive directions. And so going to the right, when the R value is above 0, you're going to start getting graphs that look like these on the right. And when the points are going in a positive direction, going up and to the right, and they're still kind of far away, there's still some distance between the points and the line, we would say that there is a weak positive correlation. And so what's happening here is as x increases, y also increases, but it's increasing loosely, not closely or exactly with the x value. A real life example of this is weight and height. So in general, right, the more someone weighs, usually the taller they are, but not exactly, because people can have different body types, and people could be heavier but also still have the same height. But in general, those two things go up together. Last type is if R is very close to 1 or exactly 1, we're going to have a positive line, and all the points are going to be very, very close to that line. So the correlation type here is to say strong positive. And as x increases, y increases very closely. An example of this is rainfall and water collected. If you're collecting water, the more that it rains, the more water you're going to have. And those two things are very exactly related to each other. And that's why they would be right on a positive line like that. Okay, so this is your spectrum of R values and the types of correlations. You can reference this slide as you complete slide 5.